Hello all. In this class, we'll discuss about follower motion, uniform acceleration and retardation. Okay. So in case of uniform acceleration and retardation, okay, so basically, we need to use angle of rise or angle of return while creating that uh, displacement diagram. So lift of follower will be given. Okay. So lift of follower will plot on y-axis and theta on x-axis. Now suppose say we have theta 0, just look at the arrangement. We have theta 0 80 degree. Okay, so we can divide, we can use scale 1 centimeter is equal to 10 degrees. So we can divide this part into theta 0 into 8 parts. So central line will be line number 4. We have 4 division towards left side, 4 division towards right side. Now to create this displacement diagram, first we need to draw a diagonal line. That is, we'll draw a diagonal line. Okay. Now what we have vertical lift. Suppose say we have lift of vertical distance is available, let's say 40 mm. So we can again above diagonal we have 20 mm distance, below diagonal we have 20 mm distance. So what we can do, we can divide that 20 mm distance into 4 equal parts. Again, upper distance into 4 equal parts. Connect lower divisional points to lower diagonal, upper divisional points to upper diagonal, and just connect the curve. So we have to take first inclined line, first vertical line, second inclined line, second vertical line, third inclined line, third vertical line. So we'll get point A, B, C, D, E. Similarly, we have fourth inclined line, fourth vertical, fifth inclined line, fifth vertical, sixth inclined line, sixth vertical, and then last 7 and 8 point. Okay. So what we have, by plotting inclined line and vertical line, we'll get the curve. So we have first point, second point, third point, fourth point, fifth point, sixth point, seventh point, and 8 point. So by joining all these points, we'll get smooth curve that will represent uniform acceleration and retardation part. Okay. Similarly, on right side, suppose say we have this 80-degree value, angle of return, divide that 80 degree into 8 equal parts, 4 parts, each part will be of, let's say 1 centimeter, 1 centimeter, 1 centimeter. So we have 4 parts towards left side, 4 parts towards right side. Again, vertical is 40 mm, so upper part is 20 mm, lower part is 20 mm. The process is same, just draw diagonal line, divide that upper 20 mm distance into 4 equal division, lower 20 mm distance into 4 equal division. Okay. So connect all these divisional points to lower diagonal, connect all these divisional points to upper diagonal. So take first inclined line, first vertical line, second inclined line, second vertical line, you will get second point. Third vertical line, third inclined line, you get third point. Fourth point will be the midpoint. Okay. Fifth vertical line, fifth inclined line, sixth vertical line, sixth inclined line, seventh vertical line, seventh inclined line, and last will be the closing point. So by connecting all these points, simply we'll get curve of uniform acceleration and retardation. Okay. Now next part is just look at the moment, or how we can draw velocity, how we can draw acceleration. Velocity is rate of change of displacement, maximum velocity value we have, okay, during acceleration and retardation. Similarly, we have acceleration and retardation values, okay, velocity and acceleration values. Similarly, if we are taking 6 divisional points, for that also we can draw this arrangement. So for 6 divisional points, we have 3, line number 3 is the reference line where we have 3 sections towards left side, 3 sections towards right side. Just draw diagonal line, just again connect diagonal line, divide that vertical reference line, that is line number 3, into 6 parts. 1, 2, 3, 4, 5, 6. So below that we have 3 divisions, above that we have 3 divisions. Connect lower divisional points to lower diagonal, upper divisional points to upper diagonal. So take first inclined line, first vertical line, second inclined line, second vertical line, third is reference point, fourth inclined, fourth vertical, fifth inclined, fifth vertical. So by connecting all these, we have this simple curve for uniform acceleration and retardation. So similarly, we can draw for right side. Line number 3 dash is the reference line. 3 points towards left side, 3 points towards right side. Again, divide that line number 3. So connect upper divisional points to upper diagonal, lower divisional points to lower diagonal, and connect first line, vertical inclined line, and pass all these, connect all these points, we'll get simple curve. So this is all about the acceleration retardation diagram when we have 6 divisional points. In previous we have discussed about when we have 8 divisional points, how to create the diagram. In this case, we have 6 divisional points, how to create the diagram. Okay. Now next, uh, suppose what uh, we have cycloidal motion. Okay. So basically, cycloidal motions, in cycloidal motion, there is no any discontinuities. no acceleration is going to smoothly. We can transmit the motion at high speed. To create that displacement diagram for cycloidal motion. So first we need to draw the circle. Now how to draw the circle? To create circle, what we have, circumference is known. S is 2 pi into r. Okay, this is the circumference value for the circle. So you can take r of that radius of circle is equal to lift of follower s upon 2 pi. Just simply I will explain you how to create that radius. Okay, suppose say we have s r value 5 mm, lift is known, 2 pi distance is known, and we are getting r is 5 mm. So by taking r as a 5, we have to draw the circle. So we'll draw 5 mm as the radius, and we can plot the circle with that radius of 5 mm. Okay, after creating that radius of 5 mm, just divide that circle into 4 equal divisions. Each part will be of 45 degree, 45 degree, 45 degree, 45 degree. And we have to provide the naming. Let's say namings are 1, 2, 3, 4, 5, 6. Okay. So after providing the namings, we have to draw a diagonal line. Okay. So diagonal line must pass through center of circle. So this is center of circle. So we'll draw one diagonal line which will pass through center of circle. Okay. Then we'll draw two lines. One line which will pass through, which will connect line number 4 and 5. Will connect 1 and 2. With respect to that, these two lines are intersecting the vertical axis. So we'll pass one line that is parallel to this diagonal line, which will pass through upper intersecting point. Second line, which will pass through lower intersecting point. These are the two lines which we are drawing. Okay, just look at the arrangement. So what we have, our curve will start from center of that circle, which will pass through these two similar lines. So it will connect two points we have below that diagonal line, and 2 points we have above that diagonal line, and all these points must pass through the parallel line. So just we'll connect point A, point B. So this lower line will provide you 2 points A, B. C is the central point, upper line will provide 2 point D, E, and final will be the closing point. So in this way we can draw this smooth curve. Okay, that will represent acceleration diagram, or okay, sorry, displacement diagram. Okay, so for cycloidal motion we have this displacement diagram. Okay, where we are using a parallel lines. Okay, with the help of parallel lines we are achieving the displacement diagram. Okay, so this is all about displacement diagram for this cycloidal motion. Okay, now next, again we can create this part. S is equal to s 2 pi r is s upon 2 pi. Just I have explained the process how to create displacement diagram for same cycloidal motion. Okay, so two lower points we have AB with the help of lower parallel line. Upper parallel line we have point DE, and that curve must pass through the parallel line. We have getting A, B, C, D, E points. Okay, now suppose say we have uh, wall opening and wall closing with cycloidal motion. At that time, what we can do, okay, to create this arrangement, if we have cycloidal motion for angle of rise and angle of return, then we can create circle at center of that particular displacement diagram. Okay, then draw two diagonal lines, then two parallel lines. Okay, upper lower parallel line, divide that circle into 4 equal parts. Okay, so upper line will define points, lower line will define 2 points, upper line will define 2 points. So simply we are getting curve A, B, C, D, E, F, G, again H, J, K, L, M, N, P. Okay, so this is the procedure by which we can trace cycloidal motion, even though we are having wall opening and wall closing. Okay, in this case, we are having wall opening and wall closing with the cycloidal motion. Okay, so this is all about to create cycloidal motion displacement diagram with the help of cycloidal motion. Okay, so we'll stop here. In next class, we'll discuss example based on these arrangements.